Hey guys, welcome to AI with AI. This side, Asif Himnat. I welcome you all to the most amazing and interesting machine learning algorithm, which is K nearest neighbor, also known as KNN. As I have said, the abbreviation KNN stands for K nearest neighbor. The K nearest neighbor is one of the simplest machine learning algorithm based on supervised machine learning technique. And any new guy in the field of computers will able to understand this. So let's deep dive and understand what it is. So before I start jumping into this slide and start talking about what is K nearest neighbor, let me give you a simple analogy what KNN stands for. We are often notified that we share many characteristics with our nearest peers. What you is nothing but the reflection of with whom you hang around, your friends, your family, your neighbors. So we carry the characteristics and the energies that people that we hang out with on a daily basis, right? Whether it could be a thinking process, working etiquettes, philosophies, whatever, so on and so forth. So, in simple words, all I'm saying here is you are the reflection of your friends and your family. And so, the KNN algorithm employs the same principles. Its aim is to locate all the closest neighbors around a new unknown data point in order to figure out what class it belongs to. It's a distance based approach. Let me explain it in a simple way. So, we have discussed this example multiple times in our previous examples in other machine learning algorithms. We have a cancer data set here. The data is plotted against age and tumor size, harmless tumors and harmful tumors. The cross ones are the harmless tumors and the green ones are the harmful tumors, and these are plotted something like this. Okay, so what KNN does, it simply looks for who is nearer to me. Let's say for example we have plotted this data, and at runtime when we deploy this machine learning algorithm and look for the classification, this is a classification problem by the way. So if any new data comes, let's say this white circle here that you see is the new data set which is coming at runtime, and we need to classify this. We need to classify whether this tumor is harmless or harmful. So what KNN does here, no training phase here, it simply looks who is nearer to me, who is nearer to this one. So the nearer data point to this new data set is the harmless tumor. You getting it? So the nearest to this data point is the harmless. So this will automatically declare and say that I am harmless tumor. That's simple this KNN algorithm is. So this is the same analogy that I was talking about, right? So we are the reflection, we carry the characteristics that we spend most of our time with our friends, our family, so on and so. So in simple words, KNN algorithm assumes that similar things exist in the close proximity. Similar things are near to each other. So that is why this new data point will declare himself as a harmless tumor. It's that simple, okay? But there is a twist here. The story doesn't end here. Let me give you a second example. We have plotted the data again, and this time the new data set is falling somewhere here. So you see this blue one is the new data set. So now we need to classify whether this blue circle here is a harmless or harmful tumor. So now tell me what machine will predict. So as you see, the nearest data point to this is again harmless, the cross one. So it will declare himself as a harmless tumor. But just by looking at this plot, can you guarantee that the new data point is a harmless one? Because there is just one outlier which is falling under this harmful tumors. That is why the new data point is also declaring himself as harmless. But actually, if you see the classification, the cluster which it falls under is the harmful tumor. So you are saying that a new person, a new patient who is visiting your hospital, you are saying that you have harmless tumor, but in reality he has the cancer. Imagine the criticality of this situation. So what should we do here? It is very simple. Why are you asking only one neighbor? Let's ask multiple neighbors what you belong to. So it is a combination of all your friends, your neighbors. So why to ask only one guy? Let's ask multiple people here. So if you ask only one guy here, so it will be definitely underfitting, right? So it will be automatically harmless. But in reality, if you ask more than one, let's say three guys out here. One is this, second is this, third is this. So these three are the nearest one, and the majority goes towards harmful. So now the result is changed. Rather than asking only one guy, we are asking two more guys what type I belongs to. So I belong to harmful tumor. Okay, so that's how simple it is. So no line drawing, no clustering, nothing. It is the simplest algorithm. Pretty amazing, right? It is so simple. Let's understand how it works. So now we know it looks for the nearest neighbor. So we need to calculate the distance. So there are multiple ways by which you can calculate the distance between data points. Who is nearest to me? Either you calculate a Euclidean distance, or you calculate a Manhattan distance, or you calculate Minkowski distances, right? So these are just different equations thrown by legend mathematicians. So you can choose the one whichever suits to use. Ideally, in 90% time we go for Euclidean distance. So there is a one parameter. The distance that you need to provide is generally a Euclidean distance that we provide, and the second parameter is number of neighbors. Okay, what should be the value of k? You see the k in KNN, right? That k is nothing but number. How many neighbors I should ask, that what category I belong to. Understand this. So it is always recommended that to select odd value of k. So if you select even numbers, see what's happening here, right? So the red circle shows the even numbers. So the value of k here is 4. So this is a new data point. So we need to categorize this new data point either as a smiley or as a sun. So that is what we need to classify, right? If I select value of k is equal to 4, then you see two smileys and two suns, then again there is a confusion. There is a tie. I cannot decide what type it belongs to. But whereas if I select odd number, let's say 11 this time, based on the nearest neighbor, based on the nearest distance, I calculate the distance between the data points and I select all 11 data points which fall near to me. Okay, so based on this we can simply see we have 7 smileys and just 4 suns. So the result would be the classification of this new data point would be a smiley. Now I can make the decision. You're getting my point. So the conclusion from this discussion is the value of k should be the odd value. It should not be an even value. So let's put this into the steps and understand how does KNN works. So what is the first step? The first step is select the number of k's, select the number of neighbors that you want to ask to, and then calculate the Euclidean distance of k nearest neighbor. Euclidean distance, you don't have to calculate, you just have to provide a parameter, how many neighbors that you want to ask to. Okay, so let's say I provide 5, odd number I always prefer. Default will be Euclidean distance. The algorithm will calculate it for you from data point 5 nearest neighbors and take k nearest neighbors as per the calculated Euclidean distance. And among these k neighbors, count the number of data points in each category. What is the majority here? So in the previous example, you see 7 smileys and only 4 suns. So I would choose the new data point as a smiley one. Okay, so this is what, simple words, your KNN does. So fifth step is again assign the new data point to the category for which the number of neighbor is maximum, and our model is ready. It is that simple. You know, the KNN algorithm is also called the lazy learning algorithm. What does this lazy learning algorithm means? It doesn't have the training phase, unlike other machine learning algorithms where we have train and test phase, right? Training phase and testing phase. Here we do not have any phases. We don't train our model. So what KNN does in the training phase? It just stores the data set, nothing else. Okay, so during training phase, it doesn't do anything. It just stores the data, and when it gets the new data, then it will classify the new data point as per the category, as per the calculation. Let me show you some more examples where this KNN algorithm should not be used. In this diagram, you can see we have two examples. So first example on the left hand side, you see what is the impact of imbalanced data set. So this is the imbalanced data set. So what do you mean by imbalanced data set? Where we have a weightage of red data points is huge and green data points is very less. We have more reds and less greens. So this is imbalanced data set. So in this scenario, if I choose 5 as k, 5 neighbors if I want to ask to define the category of this new data point, then 1, 2, 3, 4, 5. So all of these nearest data points are red. So definitely this will become red one. So this is what the imbalanced data set means. Even if I increase the value of k, let's say if I k as 7, so I will have only 1 or 2 greens and all other 5 data sets as red. So it will be again classified as red. But by looking at this plot, I can say that this can be of type green because there is a clear classification clustering which is nearer to green ones, but because of the weight of red ones, this is categorizing as the red one. So this is called imbalanced data set, where we can get wrong predictions in case of KNN. So we should avoid using KNN algorithm in case of imbalanced data set. There are different strategies in data science, nothing but upscaling and downscaling of these data sets. So these strategies we can apply and then think of using KNN. So what about this diagram here, the right one? So here, if you see, there are outliers. We have outliers. So these three data points, red ones, they are very far from the actual data points which we have. So these are called outliers. They are not the usual data points like these. These are very near to each other, whereas these three data points away from the general data points here. So whenever new data point occurs, let's say it occurs here, what is the type of this new data set? This is where you may get the wrong predictions. Again, if I select value of k is equal to 5, then 1, 2, 3, 4, 5. So maximum number of neighbors that I have is red. So I will become red, but it may not be the situation. These are just the outlier, right? And this is actually nearer to this green ones. And even if I draw a logistic regression line here, then this would fall under the green category. Okay. So in case of imbalanced data set and in case of outliers, the KNN algorithm may not be your best choice. Okay, but definitely we can think of using some strategies such as upscaling, downscaling, and feature engineering. We can definitely do that. We can definitely pre-process the data and pass it to a KNN algorithm. All right, last but not the least, what are the advantages and disadvantages of KNN algorithm? So as I have said at the start of this discussion, the biggest advantage of KNN algorithm is it is the most simplest and accurate algorithm which even a new person can learn, right? It adapts very easily. Algorithm adjusts for new data points as they come into, and it just stores the data into a memory, and very less hyperparameters. We just have to pass the value of k, that is how many neighbors that you want to ask to, and what is the distance metric, I mean which distance metric you are going to use, Euclidean, Manhattan, or Minkowski. Okay, default is Euclidean if I'm not wrong. And what are the disadvantages? Sometimes determining value of k could be complex. Okay, I cannot choose huge value of k. Let's say I cannot say 77. It is again an odd number, but 77 is a huge number. So I may have a problem of overfitting, and I cannot choose only one or two as a value of k. So choosing value of k becomes sometimes complex. It's not a big disadvantage, but yes, this is the big disadvantage, I would say. The computation cost is high because of calculating the distance between the data points for all the training samples. Because there is no training phase and the calculations are done at the runtime, it stores the data points in the memory at runtime and then calculates the distance. So there is a runtime calculation and storing all the data during the execution, and which can in return needs a more resources, more memory, more time, more value. These are the advantages and disadvantages of KNN algorithm. I hope you understood the most simplest algorithm in machine learning. Let me know if you have any questions with regards to this algorithm. If you're liking our simple explanation and able to understand machine learning, if these videos are adding value in your life, make sure to like, subscribe, and comment. And don't forget to share with your friends. Alright, so that is it for now. See you again next time. Thank you. Bye bye.